Right. So can you say where to write the extended access list? Should I write it on R1 or R3? Where do we write? Come again? Correct. Closer to the source. Why? The reason why is if I write it closer to the source with all these parameters like protocol, the source, and the destination. For example, any traffic going from this source going to this destination 10.40.0.2 going to this destination, if it is telnet, need to be dropped. That's the policy. If it is telnet, need to be dropped. So if I do it right here itself by checking the source and the destination, there won't be bandwidth consumption and process utilization over the path. You can avoid that. Same thing can also be done on router 3, but when you drop here the packet, then all the resource that was utilized here is waste. In the standard access list, you match only the source. There is no option other than writing near the destination. But this one, it's good to write near the source so that right here itself you compare the packet source and destination and protocol. If need to be denied, right here itself you deny it so that it need not to go and consume the bandwidth. Where is the bandwidth? Do you understand this or do you have any question? Ma. Did you understand why we should write near the source? Yeah, not only the bandwidth, the CPU utilization on the routers in the path. Can this be done in the standard access list? Can you write this in the standard access list to save bandwidth and the processor? Can we write near the source the standard access list for the same reason? Not possible. Why? Standard access list checks only the source. If you drop only by checking the source without checking the destination, then you may end up in dropping packet which is supposed to go to other middle networks. So when we are dropping, we should check both the source and destination. Then if you drop near the source, then it is good for us. We really save bandwidth and processor. Standard access list, write as close to the destination. Extended access list, write as close to the source. So this is the scenario. Let's take a scenario like as we spoke now, telnet access to this is denied only for this computer. This computer can do telnet, this router can do telnet, this router can do, anyone can telnet to this R0. Anyone can telnet, this is a telnet server. Anyone can telnet to this except that A. That's the task. First of all, let us enable telnet. On this router, how do you enable telnet? Line VTY 0, 4. 0, 4 means I can telnet 5 parallel connections. 0th connection, first connection, second connection, third, fourth. 5 parallel connections. And then I'm going to say if someone is telnetting, use the local database to verify them. So where is the local database I'm creating now? Username, Maggie, password, Ram. Right, so if someone puts this username and password, they'll be in. Let's go and verify this. I'm going to tell it from here. Before that, let's try pinging 10, 40, 0, 2. There's some routing issue. This router don't have the route to reach that destination. Let's check why. There is no 10. There is 1020, but there is no 1040. 1020 is there, 1030. Oh. We have given 1020. Sorry, 40. What about this? Show IP. 1040 here I have given, but on the router side, show IP interface brief. I put 30 here. I'm changing this to 40. Interface F00, IP address 1040. Now let me try pinging first. Okay, we are able to ping. I'll also ping from the other one. Ping 1040. Ping 1040.01. 01 is a server on the same network. So I'm able to ping the server on the destination as well as the telnet server. Both web server and telnet server I'm able to ping. Okay, so we are pinging the destination network from here. Both the PCs can ping. Telnet is enabled already. So I'm going to say telnet 1040.02. Maggie Ram. I'm inside. You see, I can see the test router from here. Means telnet is successful. I can also do the same telnet from here. Telnet 10.40.0.2. Maggie Ram. I'm inside. So I'm able to telnet from anywhere. Even from this router, if you want to see that router, I can telnet. I'm in router 2, but if I say telnet 1040.0.2 Maggie Ram. I'm inside, you see. Parallelly, there were three telnets. There are three telnets now. You can also verify that from here. You can ask, hey, who all have telneted? Show user. It will show you there are three people from this address, and from this address telnetted me using the session 0, session 1, and session 2. The password, same password. Three people. Let me add one more. I'm telnetting from here. 104002. Wrong. Now you go and ask this guy. He'll say there are four people. There is also another new connection with the same password from this IP address. So telnet is available from everywhere. Now let's have a scenario. We do not want to allow this guy and this guy. It's the same process. Let's keep only one. Because we are going to write on R1. I don't want to do this. We are going to say if traffic is coming from this guy, if it is coming from this router to this router, means if it is coming from this source to this router, and if it is a telnet, should be denied. As we already spoken, we need to write this near the source. I'm near the source. Let me close all the telnet session from everywhere. I'm near the source. I would like to write extended access list. What will be the access list number? It can be any number between 100 to 199. So I'm going to say access list 150. Permit. No, first let's deny. Deny the single host. Sorry, deny before the protocol. Access list 150. Deny any TCP packet coming from the host 10.10.01 going to, so we have defined protocol now. We have finished saying the source. After this optional, you can say port number, because we don't know the port number which it is going to telnet from. The from port number we do not know. So forget about that. And the destination is 104002. That is again another single IP address. So use the keyword host. If it is equal to 23, that is the destination port number. You know the destination port number because it's a telnet. You know the destination port number, but the source port number we don't know. It's a random port number. That's all. This is what I have to paste. That's the rule. See, access list 150 deny TCP host 10.10.01 to host 10.40.02 equal to 23. We want to permit all other traffics. So access list 150 permit IP. If you put IP, no, it will include TCP also. Everything I want to permit. So I don't say permit TCP. If you say permit TCP, which means you want to deny UDP. Implicit deny will do UDP. It will deny UDP. So we have to say access is 150 permit IP, any source, any destination. Boom. That's it. That's all. So you have written an access list. This is like a decision made in your director's room. Now, if you want to deny someone, you need to call the security guy and say we have decided not to permit this person during the working hours, something like that. So that needs to be done. Now I need to go and call the security guy. Where is the security guy standing? He's standing in the gate. There are two gates. There's an inside gate, there's an outside gate. Where do you want the security guy to apply? If it is outside gate, call this guy. Outside gate. Interface F0/1. Now he is here with you now. Tell him IP access group. Follow this order 150 whenever the packet goes out. Whenever the packet goes out of this router, follow 150. What does 150 says? Check whether the packet is a TCP packet coming from this host going to this host with this port number. If yes, deny. All the rest you can permit. Alright, so because it is the F01 security guy, outside gate, you say outside. If you would have written it in the F00, then you should have said inside. When the traffic comes in, you drop it. You can do it any way that you like. The only difference is here, the packet is received, processed, and while it was about to send out, got matched and dropped. If I will write it in F00, then before finding the exit interface, it would have got dropped. Please ask me any question if you have.
So you can also write it F00 interface.
Why not? Why not? That's what I said. You can write it there. The reason why I did not write it here is, let's assume mostly in the real network we don't have simply like you know uh, one router, one connection, one outside. No, it won't be like that. It will be something like this also. So if I will block here, then he will not be able to go here also. No, nothing wrong. Yeah, even then you can write that. Anyway, it's going to check the source and destination. Very well, you can write on F00. Only thing is you say inside instead of outside. You can do very well on F00. Right now, I'm going to verify, check this. Mhm.
The statement that you've written, it's only for the telnet service, right? Denying the telnet service routing.
Yeah, from A to router 0. So let us telnet from router, the B PC, the computer at the bottom, this router, this PC. We have not denied this guy. So if I telnet now, it's asking password. I can telnet. If I telnet from this router, I can telnet. Username is, I can telnet very well. But If I'll try telnetting from this PC, it will not. It will time out. You see? The reason is this router here, firewall, acting as a firewall, you see show access list. It says I denied 12 telnet packets. Means 12 packets got generated when I telnetted from this. Let us telnet again and see how many packets it generates. Another 12 packets. So there should be 24 packets if I check it now. Okay. See, 24 packets. So for each telnet, it generates 12 packets. Got denied from, and there were 23 packets permitted. One was I was telnetting from here itself, other was I was telnetting from here. So we can see that only this PC cannot telnet, all the rest can telnet, including this router where we have applied the access list. The reason why I had written on F01 instead of F00 is if I want to deny this guy also from telnetting, I can do so. I can do so now. But if I write in the F00 entrance, then I cannot filter because when router 1 telnets, F01 IP address is going to be the source. Okay, so we have written one example denying this particular PC in telnetting. But can this PC ping? This is not telnetting. Will it be able to ping? Of course it can ping. There's no problem in pinging. He can ping that server, but he cannot telnet. Because only the telnet service is denied. Ping is not a problem. So the ping is also matched in any statement. Just any statement. Say I'm going to ping 100 times. -t timeless. So there's going to be many ping now. We'll say at least 10 ping has gone already. So I should see at least 37. 44. Good. So that ICMP is not matching in the first statement. It matches in the second statement where it says IP any, means any IP service. ICMP is one of the IP service. Okay, next. Let us also deny this PC doing HTTP to this server. Let us design a web page. Go here. Right? Go here, configure. No, services. You see HTTP tab. HTTP is on. Now let us change the color to pink. Instead of Cisco packet tracer, we'll say access control list. Welcome to CCNA network. All right, so we have done all this. Size, let's make it a 6. Okay, now let's go and test this. Before denying, I'll test from here. 104001. It should not be denied. Of course, it is not denied. I can see pink color access list. I can see welcome to networking, opening doors to the new opportunity. Let's change the color. That's too dull pink. I'll say red. Now go and refresh the page. It will become red. It has become red. So here we go. We will go to this computer also and try to do HTTP 1040. We got the same page. Let's go and change the color now. Refresh the page, it should become blue. Yes. Refresh here also, it should become blue. Okay. So we see that HTTP is working fine. Our aim is to deny HTTP from here. All the rest should work. The telnet, which is working right now, must work. Only this should not work. He can telnet like he does now. Yeah, this should work. Ping should work. Yeah, all this should work, but only the HTTP should not work. When I come next time and type this, I should not get this page. Instead, what will come, a request timed out. Request timed out should come. Let's do that. I'm going to edit this existing access list. If it is numbered access list, editing is not possible. I cannot insert a value in between these two. This is 10 and this is 20. I cannot insert a number. So I'm going to remove the standard access list, named numbered access list. I'm going to remove the numbered access list. I'm going to have this denying telnet with the named access list, and then we'll go and edit. I showed you how to edit in the previous class. It's the same way. You need to just go and add the sequence number and add in the middle. If you don't put sequence number, it will become 30. After saying permit any, you cannot say 30 deny. That is not a logic. Okay. It's doing IP domain lookup. Okay, fine. If you want to avoid this waste of time, say no IP domain lookup. Now if I do the same mistake, it won't allow me, it won't waste my time. Okay, now where we are, we want to remove the access list. No access list 150, boom, everything is removed. Now everyone can telnet, even this guy can telnet. Earlier this guy was not telnetting, now this guy can telnet. Say asking password. Okay. So our aim is to put back the same access list. Instead of number, we are going to use name. IP is the syntax, access list. extended, given name, policy 1. Deny TCP coming from host 10.10.01 going to the host 10.10.10.40.02 equals telnet. You can say telnet or you can also say 23. Everything is okay. Permit IP any. Now if you check the sequence number of these two lines, it will be 10 and 20. Show access list. 10 and 20. If I need to insert anything, I need to put some number between 11 to 19. Let us apply this to the interface. This time I'm going to apply it on F00. Interface F0/0, IP access group, policy 1, in. As the update comes, as the traffic comes into this router on this port F00, I need to take these actions. Okay. Now, after applying, let's go and verify show access list. I can see there is no match. As of now, there is no match. It's a fresh one. The access list name is pool1. Let me do the telnet again. Telnetting, not happening. But from the other PC, the telnet should happen. It should happen. Yeah. So the telnet is not happening from that PC where we do not want. So verify now. You see there are 12 matches on the telnet denying and 27 matches here. But from there you will be able to ping. Ping is not a problem. Only telnet connection timeout. You are able to ping. From here also you can ping if you want. Right. So this one policy is achieved. You got another policy. What is that? This second PC down here can do everything except HTTP to the server here. Right now it is doing that HTTP. It should not. It can ping that HTTP server, no problem. But it cannot do this one. This should not happen. Let us go and block it. Go back to the same access list called pol1 and put the sequence number 11 and say deny TCP from the host 10.10.02 to the host 10.40.01 equals HTTP. Okay, equals 80. If you don't want to put 80, then you can put www. See, some operating system will allow HTTP. Some operating system will allow www. Both are same, 80, www, HTTP, all are same. Now let's go and verify this. Show access list. You can see here www. Added as the 11th one. It got inserted in the middle, which is not possible with the numbered access list. Now, if I go to the first PC and ask for the web page, there will be a web page 10 No problem in this. But when I go to this computer and ask for the web page, it will request timed out. It won't. It will say request timed out after some time. After request timed out. But the same IP address, when you ping, the ping happens. It is because of the permit any statement at the bottom. Yep. So there's a new match here. Web page blocked. So that brings us to the end of the topic called access control list. You can have any example. I have done one telnet and blocking telnet and HTTP. Likewise, you can block various other services. All that you need to know is the port number. Any question?